Be sure to wear proper PPE before beginning. First, we take our sample and take a preliminary measurement. To begin with the low-speed saw, fill the fluid basin with soapy water. Next, load in the fluid basin. Remember to turn on the saw. Set the saw speed to 3 and use the sharpening blocks to sharpen the blade. Use the Allen wrench to loosen the bolts on the sample holder to clamp the sample in place. Use the calipers again to measure the sample in the sample holder. Now use the screw to attach the sample holder to the saw. Be sure the center of the sample is contacting the saw blade. Use the pliers to tighten the screw and use the fine-tune knob to fit your desired dimensions. Perform a quick test cut to check your cut dimension. Once satisfied, put the weight on and let it cut all the way through until it stops on its own. Use the pliers to loosen the screw to retrieve the sample holder. Use the Allen wrench to loosen the bolts on the sample holder, allowing you to retrieve your sample. Remember to turn off the saw and reposition all the tools.
Once your sample has been cut, turn on the hot plate in order to prepare for polishing. Remove the liquid basin from the low-speed saw and clean it. Once your silver polishing fixture is hot, apply crystal bonding. Then place your sample on the center of the polishing fixture. Use heat-safe tongs to transfer your sample from the hot plate over to a heat-safe surface for cooling. Prepare your materials for polishing calibration. To begin calibration, remove the lid and turn the polisher on. Align the hole marked with an A to the peg marked with an A. Take the dial and attach it to the calibration tool. Ensure the top side is facing up. Align the tool about 1/3 of the way from the bottom. Ensure the needle is at 0 and adjust the arm to 45 degrees backwards. Attach the arm and ensure the red knob is to the back of the slot. Tighten and raise the arm. Attach the calibration tool and tighten the red pin. Set the platen RPM to 10 and use the oscillate button to bring the arm of the dial to the edge of the platen. Once the dial is on the edge, press the oscillate button to stop the arm, then lower the arm until the dial reads 100. Press the green button to rotate the platen and make sure the dial remains within 2 step sizes of 100. If it deviates too far, raise the arm and wiggle the platen, then repeat the last step. Now we will calibrate the arm. Raise it back up and use the oscillate button to bring the arm back to the center of the platen. Use the full button to rotate the dial to 3 o'clock. Lower the arm so that the dial reads 100. Then, press the full button again to rotate the dial to 9 o'clock. Now we will make adjustments to the dial to bring it back to 100. Use the proper Allen wrench to adjust the back right bolt until the dial reads 100. Press the full button again to rotate the dial back to the 3 o'clock position, and repeat at 3 and 9 o'clock until no additional adjustments are required and the dial stays within 2 step sizes of 100. Rotate the dial to the 12 o'clock position and use the mirror to confirm the dial reads 100. Raise and lower the arm to adjust. Then rotate the dial to the 6 o'clock position and use the Allen wrench to adjust the front center bolt until the dial returns to 100. Repeat until no further adjustments are needed. Remove the calibration tool and take off the dial. Rotate the dial so that the needle points to 100. Flip the dial arm so that it is pointing 45 degrees upwards. Then attach double-sided tape to the bottom of the dial. Take out the calibration polishing fixture and attach it to the head and tighten the red pin. Press the full button until the silver screw is at the 6 o'clock position. Align the screw with the dial arm and attach the dial on the platen where the arm is at the edge of the fixture. Lower the arm until the dial reads 0. Use the full button to rotate the head to the first silver knob. Gently adjust till the dial returns to 0. Repeat at the next silver knob. Rotate to the screw and raise or lower the arm accordingly. Iterate through until the head can rotate 360 degrees and the dial remains at 100. Now you are calibrated. Remove the calibration tools and unscrew the arm so you can place your first grip paper. Secure the paper with a silver ring. Take your cooled polishing fixture and attach it to the head with the red pin. Rotate so that the red pin is at 3 o'clock. Set the RPM to 100 and turn on the water to saturate your paper. Lower the head until the sample surface makes contact. Follow the numbered boxes to go from the largest to smallest grit throughout the polishing process. For some of the other grit papers in the progression, lightly wet the platen and peel off the adhesive and press the paper down. In between each grit, use the optical microscope to ensure all the grooves are going in the same direction and no outlying scratches are present. After all the grit papers have been used, replace the platen for the magnetic one. Start with a 3-micron polishing pad. Lightly wet the pad before placing it on the platen. Spray the polishing pad with a green lubricant and the 3-micron diamond sprays. Reapply sprays every 3 to 5 minutes until sample surface is pristine. Reattach the arm and secure the polishing fixture. Press the green button to start rotating the platen, then press both the oscillate and full buttons. Lower the arm until the sample makes contact. When you're finished, exchange the 3-micron polishing pad for the 1-micron polishing pad. Repeat the prior steps using the 1-micron diamond spray, reapplying the sprays approximately every 2 to 3 minutes. Check for a mirror finish in the optical microscope. Now we will clean the sample to prepare for final polishing. Fill a small dish with water and a few drops of microorganic soap. Put the dish in the ultrasonic cleaner. Fill the basin with water and put the sample into the dish. Press the start button for a 5-minute cleaning cycle. While the ultrasonic cleaner is running, prepare the vibratory polisher. Remove the pieces from the machine and bring the pad over to the sink to rinse. Place it on the polisher with the indicator facing you. Align the top ring using the indicator. Put the bolts in their designated spot and use the wrench to tighten them in a star pattern to ensure an even seal. Pour a layer of the non-crystallizing colloidal silica until it just covers the polishing pad. When the ultrasonic cleaning cycle is finished, take the polishing fixture and rinse it with water. Place it face down in the vibratory polisher. Turn on the polisher, press the white oscillate button, and set the amplitude to 20%. Now we will prepare for final cleaning. Lay out the beakers labeled A and E. In the flammable cabinet, take out the acetone and ethanol. Fill small amounts of each in their respective beakers. After confirming the sample has a mirror finish, heat the polishing fixture to melt the crystal bond. Using tweezers, gently remove the sample and place it into the acetone beaker. The acetone will remove any residual crystal bond on the sample. Fill another dish with water and microorganic soap, mixing with a cotton swab. Use the tweezers to take the sample out of the acetone and place it polished side down in the colloidal silica left in the vibratory polisher and gently move it around using your finger. Then bring it back to the sink and gently rinse with water. Place the sample polished side up on a CAMM wipe and use the cotton swab from earlier to scrub the sample surface with the microorganic soapy water. Rinse the sample with water one more time and then place the sample in the ethanol beaker. Remove the sample from the ethanol using tweezers. Using a hairdryer or heat gun, move the sample so that the airstream hits the surface at a 45-degree angle. When finished, place the sample safely in a membrane box.
Pre-irradiation, we also do a variety of preliminary characterization. To prepare the sample for microscopy, we attach the sample to an SEM stub using a small piece of carbon tape. Take the SEM stage out of the desiccator and place the stub in one of the several stage positions. For ease of imaging, we chose the center slot. Use the small screwdriver to tighten the grub screw, securing the stub. Load the sample stage into the SEM and pump the vacuum. With the proper SEM training, you're ready to image your sample. Other microscopy characterization techniques include electron backscattering diffraction, also known as EBSD. This allows you to see the crystallographic orientation of grains within the sample. We can also do energy dispersive spectroscopy, or EDS. This technique is best used for chemical characterization of the sample, and it provides both an X-ray spectrum and an elemental map. Using a focused ion beam, or FIB, we can lift out nanometer scale samples from the bulk material that will later be used for characterization in a transmission electron microscope, where we can do atomic resolution imaging and also image any small-scaled features from radiation damage. X-ray diffraction can be used to analyze the physical properties of the material, such as phase composition, crystal structure, and material orientation. Lastly, we can use nanoindentation to test the mechanical properties of our material.